All right, so in class we found the discontinuities on this graph and classified them, but we hadn't had a chance to talk about the interval over which the function is continuous. So let's do that now. So I mentioned in the notes earlier that a function's continuity is often defined in terms of its discontinuity. So if I'm looking at this graph, this function will be continuous, here, and 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 here, here, and then you have this one discontinuity here, and it's continuous here, 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 here. So you have basically an infinite number of points that are continuous and a finite number of discontinuities. So when we're writing where a function is continuous, it's easiest to write where it's not continuous and base everything off of that. So we're going to write x is an element of. We're going to write this in interval notation. And I'm going to start from the left of the graph. So this graph keeps going off to the left. So it starts at negative infinity. And you can never include an infinity because you can't actually reach it. And it's going to be continuous all the way up to the point of the first discontinuity, the first point of discontinuity, which is at negative 3. Union. And then it starts at negative 3. And again, not inclusive because it's not continuous there. The function's defined, but it's not continuous from both sides there. All the way up to 0, union, 0 to 2, union, 2 to 5. And when you get to 5, if this had been a closed point, because it is an endpoint, we would only have to worry about the limit approaching it from one side. So we would have included it had the point been closed. But since it's open, we don't. And this would be where the function is continuous. It's basically the intervals of everywhere it's defined with the discontinuities removed.